Hey gang, we're going to talk today about some sine graphs, cosine graphs. This first video is just going to lead us through what are all the parameters, what do they mean, what is A and B and H and K. And then subsequent videos we will look at specific problems, going from graph to equation and equation to graph. So I want to start here by looking at these two equations. In red we have y equals 2 sine 2 times x plus pi over 2 plus 1. And then the blue graph is the general form for a sine curve. Just like we've seen general form for quadratics, cubics, square root functions, we have one for sine and cosine. And in particular, when we graph sine and cosine, we focus on 5 points. So sine always starts, when we haven't done anything to it, it's going to start at 0, 0. And then it's going to end, one cycle is going to end at 2 pi 0. Okay. If we go from 0, 0, and we follow that along, when we get to 2 pi 0, that cycle is done and the next cycle starts, and it just repeats itself. So we're interested in that first point of 0, 0, that last point of 2 pi 0. Also, if we go halfway between those at pi 0, you can see that's at the same height as the first point and the last point. If we go in between 0 and pi, we're at pi over 2. And you can see that that puts sine at its highest point, at pi over 2, 1. And if we go halfway in between pi and 2 pi, that puts sine at its lowest point, at negative 1. Okay, that's your basic sine graph. I want you to start from that point anytime you're dealing with sine. Okay, I would always just draw that or sketch that graph out first thing you do anytime you're trying to graph sine. Okay, so now let's take a closer look at A, B, H, and K. And I'm going to start off with K, because I think that's probably the easiest one. So K, just like in your quadratic functions and all of our other functions that we looked at, K is the vertical shift. So right now you can see K is 0. 0 runs right through the middle of my graph vertically. So if I want to look at this red graph, and I can see that the middle of this red graph here, okay, well, it goes up to a height of 3, and it goes down to a height of negative 1. So the middle of that graph is going to be at positive 1. So if I take my K value up to positive 1, then the middle of this blue graph should be the same place as the middle of that red graph. So let's see if I take that up to positive 1. Okay, and now we can see the middle of each graph is the same. Okay, that's where this plus 1 comes from at the end of the red equation. That's our K value. That moves it up and down. Okay, so just so you can see, as I move K around, moves it up and down, we want it to be at 1. Now, let's look at the A value. So the A value, just like in our other graphs, would stretch the function vertically. So right now, we can see our graph isn't tall enough, doesn't go up high enough, doesn't go down low enough. Well, the A value basically tells you how far is it from the middle of my graph vertically to the highest point. Or another way you can think of it is what's half the distance from the top to the bottom. So right now on the blue graph, we're going from 0 up to 2. Half of that distance is 1. We can see the A value is 1. On the red graph, we're going from negative 1 up to 3. That's a distance of 4. Half of that is 2, and that's our A value. So if we want this blue graph to have the same total height as our red graph, we need to increase that stretch factor, that A value, to 2. Just so you can see what happens with the A value though, if I shrink it, it's getting flatter. If I make it negative, it actually flips it upside down. And then as I make it bigger, it stretches it taller. Now we said we wanted it at 2. So let me just bring that back down to 2. And now we can see that the graphs have the same total height as well. So now they both have the same height. They're both centered vertically at the same point. Now we need to figure out how to move this graph over. We'd like things to line up a little bit here. So if we're talking about a sine graph, usually sine graphs we would start in the middle of the graph. Remember, the original sine graph we had started at 0, 0. That was the middle of the graph, and it went up from there. So that's typically what I'm going to look for when I'm trying to come up with an equation of a sine graph. So this point right here, okay, this point right here, is about the middle of our red graph vertically, and it's going up from there. So I'm going to use that for my starting point. That's my h value. So my h value is negative pi over 2. Okay. Remember, when you plug it into the equation, it's x minus h. So it's going to become x plus pi over 2, which is what we have in this red equation. So I'm going to have to change what my h values go by. So I'm going to change this to be pi over 4. Okay. And so now you can see, and let me just pause it, you can see as that h value changes, the graph is moving left and right. Now this is a little bit tricky. What's pi over 2? Well, it gives us a decimal here. Pi is 3.14. So pi over 2 would be half of that. So it should be around 1.5, 1.6, and we said negative. So if we just take it back, there's negative 1.57. That's negative pi over 2, and we can see right there, that's where we wanted it, negative pi over 2, 1. So now we've gotten this graph so that the vertical center is at the same place, the height is the same, and the h value, the starting point, is the same. The only problem is this graph goes up and down too slowly. We want it to go up and down faster. And so that's where our very last value comes in here, the b value. Okay? The b value can also be called the angular frequency. And the b value tells you how many cycles will be in 2 pi. Okay? So one thing that I can do is I can look at this red graph and I can say, okay, if I'm going a distance of 2 pi, so let's say I'm starting here at negative pi over 2. Then I would go pi over 2 plus another half pi, that would be 1 pi, plus another half pi, okay, that's 1.5 pi, plus another half pi, that's 2 pi. So I can see that if I start here and I go along this red graph, I've completed 1 cycle, and then I start over and I complete a second cycle. So in a distance of 2 pi, okay, I'm completing 2 cycles. Sometimes it's easier to look at the peaks. So you could also look at the peak and say, all right, from negative pi over 4, I would need to go out to 7 pi over 4, because that would be a distance of 2 pi. Remember, 2 pi is the same thing as 8 pi over 4. So if I'm start at negative pi over 4 and I add 8 pi over 4 to that, now I'm at positive 7 pi over 4. So sometimes that's easier to look at the peaks. You can still see, though, that that's 1 cycle and then a second cycle. So 2 cycles, that means my b value needs to be 2. And you can see as I change this b value what happens. If I make it smaller, it spreads it out more. If I make it bigger, now it comes closer together. Okay? And we said we needed that b value to be at 2. So let's bring that b value back to 2, and sure enough, they overlap. Okay? So just a quick recap. K is the middle of your graph. Okay? So the middle of our graph vertically was 1. So K was 1. A, you can either think of as the distance from the middle to the top. So from 1 to 3 is a distance of 2. Or half the distance from the bottom to the top. So half of 4, which is 2. H is your starting point. Now again, and we'll look at some examples in other videos, but you can really choose your own starting point on a lot of these. So you want to choose a point that you feel most comfortable with. For example, I could have started this graph over here at positive pi over 2, because it goes up from there as well. Or 3 pi over 2. Okay? Anytime I'm finishing a cycle, I could start my graph there. So that's H. And then B tells you how many cycles you're going to get through in a distance of 2 pi. Okay? And we'll look at another way of figuring out B in another video where we actually use the period length in order to calculate the b value. But hopefully this gives you a good start on what you need to know about A, B, H, K, and graphing form for sine.